All right, moving on over to what we got for today. Oh my goodness, where did it go? Let me go ahead and just get a new one of these. All right, that one was from my... All right, so by the end of this section, you'll be able to determine the solutions of piecewise functions and graph piecewise functions, find the value of given inputs for greatest value functions, and graph the greatest value functions. That second part, like I said, I'm going to break this into 2 days, so it's going to be kind of a, I don't know if I could call it a shorter lesson or whatever. But like I said, this is for the enrichment week, and we can go over some more of this week's packets on Wednesday. That's my plan anyway. So a piecewise function is made up of 2 or more functions. So it's like you just get one function and you put it in with another function, and then you got a piecewise function. And piecewise is like made of pieces. It's like kind of literally what it means, made of pieces. So you know that every function has inputs and outputs, right? You put something in, you will get something out. So you put in toast into a toaster, you will get toast. Wait, no, wait, you put bread into a toaster and you get toast. But where does the bread go? Anyway, so with this one, it looks kind of confusing at first because everyone looks at these and they're like, oh man, I don't know what any of this means. So it just means your function. So in this case, I have f of x. And if x is less than -2, you use this function. If x is greater than or equal to -2, then you use this one. Pretty simple, actually. So let's go ahead and use on our first ones here. So I have f of -5. So x has been removed and replaced with -5. So x is now -5. So I'm going to plug it into this and see if it's true. -5 is greater than -2. All right, that's false. -5 is less than -2. That's true. The mouth is open towards the bigger number. So that means we use this top function here. So I'm going to grab x squared minus 1, and I'm going to replace with -5. So -5 squared minus 1. -5 squared, so that's -5 times -5, so that would be 25. And now we only have one more step, so we just got to write it in function notation. So f of -5 equals 24. And there we go. That's it. Now for the next one here, part B, f is -2. So x has been replaced with -2. So we got to find out which one of these to use. Now they both have -2 in them. So maybe it's this top one. So -2 is less than -2. Well, okay, that's false because they're both the same. So they can't, one of them cannot be greater than the other if they are the same. So it's probably going to be this bottom one. -2 is greater than or equal to -2. So because that one has the or equal to, it falls into this bottom function here. So I'm going to go ahead and plug it into this bottom function, 5, and replace x with -2. So 5x plus 3, and evaluate it. 5 times -2 is -10. And f in this case is, let's see, -10 plus 3, that would be -7. Oh, wait, no. That would be -2 equals -7. There you go. Now for the last part, part C. So f of 7. So the function, if I input 7, what is my output? Now, again, I have to look at these if statements. Is 7 less than -2? No. Is it greater than -2? Yeah. So we're going to use this bottom one again. So I'm going to plug in 7 for this one here. So you got to find out which one of these it goes into, right? Because it's going to be different. It's like different rules for different people, you know. And I'm sure you can think of some examples where, you know, the rules might be a little bit different. You know, an example might be in a PE or a fitness exam. You know, boys may have to do more push-ups. That's just an example. You know, there's like different rules for different people. So it's just telling you, you go here for this, and if X is here for that. So in this case here, F of 7 is 38. Yeah, that looks about right. Okay. Now for this one here, it's the same thing, but it's got 3 functions, right? And one of them tells me if X is less than 4, use this one. Now, the one I really wanted to talk about is this middle one, because this one, we have seen these before, but they're not really that common. And this is a between statement, because X is greater than -4, but it is less than 1. So we say that X is between -4 and +1. And for the last section, we have X values greater than or equal to 1. So let's go ahead and start plugging these in. So 2. So G of 2, which one of these do we plug it into? Okay, so in this case, 2 is less than -4. Okay, that's false. 2 is greater than 1. Okay, so it's going to be this one here, because 2 is greater than 1. And it's not between -4 and +1. So let's go ahead and plug it into this one here. So this one has a couple of extra steps. 2x, but I'm going to replace the x with 2. To the 3 power plus 9. So in this case, 2 to the 3 power is going to be 8. Because 2 times 2 times 2 would be 8. Now, follow your PEMDAS, okay? This is one of those things that I've been I talk to people about this. Make sure you follow your PEMDAS, because you've got to take care of your exponents before you take care of your multiplication. So in this case, again, I notice a lot of people will multiply it first and then take care of the exponent, but you're going to get a different answer. In that case, you would probably get something like 16 or, okay, hold on. Well, you'd get something a little bit bigger. Yeah, about 16 or 32 or something like that. But anyway, let's go ahead and multiply these together. So now we have 2 times 8, which is 16, plus 9, and this comes out to 25. Now I really should write that in G of 2 equals 25, because it tells me when my input is 2, my output is 25. But I'm out of space, so I'm going to go ahead and just leave that one as is, and let's move on to the next one. So in this case here, G is -1, so G of -1. So I have to find out which one of these it belongs into. So it's not greater than 1, and it's not less than -4, so is -1 between -4 and 1? Yeah, it is. So since it is, I'm going to plug it into here, into this function here. So again, use this function if the x value is between -4 and 1 is how you would read that. So negative of -1 minus 1. And here I have the opposite of -1, so that would just be, well, +1. And I get 1 minus 1, and we are pretty much done with this. G of -1 is 0. So if I input x as -1, my output is 0. All right, let's look at the last one, part C. And in this case, it's -6. So my guess is that it's going to be this one, because we haven't used that one yet. -6 is less than -4. Well, that's true. Remember, if you have two negative numbers, the bigger the negative number, you know, the more well, the less it is, I don't know how you would say that, but yeah, well. All right, so let's go ahead and plug it in. So 1/2 times -6 plus 3. So now we need half of, let's see. Okay, so half of -6, that would be -3 plus 3. So there we go, -3 plus 3, that would be 0. So g of -6 equals, the output would be 0. And that's kind of a weird thing because in this case here, since we're talking about two different functions, sometimes weird things like this happen. Okay, so sometimes you might look at that and say, wait, hold on, I got two outputs of 0. Well, they're both different functions. Okay, now I have a quick question about this one here. So shouldn't this be a negative? Not necessarily, because it's -5 times -5. So a negative times a negative would be a positive. So that's why this is going to be positive 25 and not negative 25. Because when you have it in the parenthesis, like this, that means the negative also gets squared. But if you have something like this, let me go ahead and, if the negative is on the outside, then that will be -25, because yeah, the parentheses do make a difference on where you put them. So make sure you put those parentheses in the right spot. But yeah, that's correct though. All right, so now we're gonna have to move on to graphing them. Graphing them is actually pretty easy. We have all of the groundwork for graphing them. We know how to graph linear functions. We know how to graph inequalities. And we know like for graphing inequalities, we know the difference between a closed circle or an open circle. We're just gonna bring it all together now. So the first thing we're gonna do is I'm gonna kind of, I don't know what I should call this. I don't know if there's an official term for it. But I'm gonna go ahead and put a marker at where the line changes. So we're gonna we have two functions, which means we're gonna have two lines. And these lines are, well, if we read this, we're gonna see where their area is. So I'm gonna look at the if statement on this one. If x is less than -3. So that means I'm gonna graph it only for values less than -3. So that means this line is only going to exist in this area. All right, it only exists here. And then I have a second segment where x is greater than -3, which means the second line is only going to exist here. That's it. All right, so let's go ahead and try to graph it. Now, one thing that kind of helps is to rewrite it now, because like in this case here, it's like, how do I graph this? There's just an x. All right, so let's go ahead and write the whole thing out. So f of x, if you remember, that can be switched out for y. So I'm going to write it in a way that you might be more familiar with it. Y equals, man, my palettes are not switching. Y equals x. And then I'm also going to graph this second one here. Y equals -2x plus 1. All right, so my first function is going to be green, and I'm going to just keep it like that for the rest of this lesson. I'm just going to keep those colors. So it's the first one's always going to be green, the second one's always going to be orange color. All right, now normally I'd graph it like this. This is what a normal graph would look like. Now we drew this light line here, and if you're using pencil, kind of mark it a little bit lighter so you can erase it. Because like I was saying, this green line only exists for x values less than -3. So I'm going to shorten that line. to about there. All this is going to be gone now. Because again, it's only if the x is less than -3. If I go to x of -2, I should not be able to use this line because it's telling me only if it's less than -3. Now I'm going to graph the second line. Now this one might fill the gap. So I wrote it in slope-intercept form so it'd be easier to read. So I'm going to go ahead and start up with my my y value. Remember, yesterday I made excellent breakfast. Start your day with breakfast. So we start at well, in this case here, we'd start at +1 actually. And follow the slope. Down 2 over 1, down 2 over 1, down 2 over 1. Now continue back in the other direction as much as you can. But we're going to have to stop at that boundary line. That boundary line is, again, the marker that tells us to stop right there. And I don't know if there's a way you could, like, again, if you're using pencil, just to write it lightly, because you are going to need to erase that line. It's not part of the graph. All right, so you don't want it to be confused with a vertical line or anything like that. So that's why we erase it. We can't have that there. Now, just like graphing inequalities, you're going to have an open circle or a filled circle. And you're going to use this part here, our if statement. So x values less than or equal to -3. Now, again, this one has the or equal to, so we are going to use a filled circle or a closed circle. And we are going to use this statement for this one here. So this one here says for x values greater than -3, since there is no or equal to, I'm going to go ahead and use a open circle, or I call it the hollow circle sometimes, to mark it out. Now, why is that important? Well, don't forget, this hollow circle, you cannot land on it. So if you tried to land on the number of x equals -3, you would go right through that, but you would land on this line. Now, a function cannot have x values repeat themselves. So a lot of these will try to avoid having areas like, you know, there wouldn't be two filled areas, because if there was two filled areas, then it doesn't work anymore. It doesn't work as a function because it will not pass the vertical line test. And again, if you go to -3, you know, you have a choice. Either go to the orange line or go to the green line. In this case, you would go to the green line because that's the one that's filled in. So that's why that's important. Last thing we need to do is find the domain and range. For this, we have to find all the possible x values. So my line, my green line, goes all the way down to -infinity. It goes to the left. Even though it's going down, it's still going left. And that means that it's going towards -infinity. The orange line, it's also going down, but it's still going to the right. And that means it is still going towards +infinity. So in this case here, we would say all real numbers. So any number that I can make x become will return an output. So if I said x of 5, or maybe 4, I'm gonna go with 4. If I said x of 4, I would probably get something like y is -7.5. And I'm just using the graph. It might be something a little bit different. You know, I might be like a decimal off. But that's why we try to draw the lines as precise as we can. Because sometimes we need to look at these graphs and get outputs and inputs from them. Okay, now the range is a little bit of a tricky one because the range is all the possible y values that you can have. So starting from the bottom, we imagine a horizontal line coming up, and you know, at some point we're meeting both the orange and the green line. And after a while, we're only reaching the orange line. And once we get near the top of the graph, there's nothing above that. we have no function lines above that area. So we don't have a full range of y values. So we can only pick y values that are less than, in this case, what seems to be 6. Now, my line might be a little bit off, actually, because I'm looking at it a little bit closer. And I hope that I did not make a mistake on that, because it just looks a little bit off. -2. No, I guess I'm right. Ah, darn it. Okay. Yeah, so any y value less than 6 is the way you would write that. All right, so let's go ahead and move on to the next one. This is not from this week. This is last week's packet. Yeah, so you are right. This is actually the week before's packet. It's not this week's packet. We did not cover this part, so we're just gonna go back and cover the ones we didn't cover. So this week's packet's gonna be mostly review, and it kind of works out too, because we're supposed to have classes and we're supposed to have other things in there. Anyway, let's go ahead and cover this one here. So g of x, and we have the lines break at -1. So I'm going to go ahead and make a light line here at -1. That way I know where to stop my lines when I'm graphing them. And I'm going to go ahead and, if you want to, again, put these into slope-intercept form. And I recommend that, especially like with some of these, like in this case, this one looks a little bit weird looking at it because it has no slope. The x value is missing, so this means that, well, okay, well, we'll get there when we get there. Well, let's first graph this line here, y equals -3x minus 7. Now again, normally we would graph and go down 1 over, or sorry, down 3 over 1. But we're going to have to go backwards now. Our line should still be negative, so it should still be coming down. Down 3 over 1. So I'm going to have to try my best to graph this down 3 over 1, down 3 over 1, 3 over 1. So I got to go, I'm going backwards. So I'm going up 3, back 1. There we go. Now I'm going to shorten this line so that it barely stops a little bit short of that, because I might end up having to put a circle in there, like a open circle or a closed circle. Now I'm going to need to graph this second part here. So y equals -5. So again, there's no slope, which means there is no x value. And if there's no x value, that means it is not going to intersect with the x-axis. So if there is no intersection with the x-axis, that means it's going to be parallel to the x-axis. So y equals -5. So that's our best way to graph it. All right, cap it off. So looking at our green line, this first one's the green line. And again, we want values less than or equal to -1. Now there's no or equal to, so we're gonna have to use an open circle for that one. This one does have an or equal to, so we're going to use a filled circle. Now, sometimes these domain and ranges get pretty tough. Now, with the domain, the main thing you're looking for is if there are any holes or gaps in this line. So if I'm passing a vertical line from, from the left moving to the right, we go down the green line and then we run into an area with a hole on the green line. But luckily it's covered by the orange line below it. So there are no holes in this line because, again, even though we look at -1 and it passes through the green end, it will reach the orange line. So in this case, the domain is all reals. Range, however, is a different story because as I go up, I run into the orange line. So I end up with y equals -5. Now you could also use a comma, but if you go with the other one, they use in this case, I'm just going to use a capital U for union. Okay, so we have one, but there's also another gap here. So we run into a gap on the range. So if you imagine a line like here going sideways, you notice it's not going to touch any of our graphed functions. So that doesn't count. We don't have that area. So to keep writing that out, we would have another set of range of y values greater than -4. So the range is values equal to -5 and greater than -4 is the way you would read that. And there you go. We're just going to go through these 4 more, and then that'll be it for today. Like I said, I'm going to just sort of break this into 2 parts. I think it's a little bit easier to digest, plus that it fills out the week a little bit better. Okay, so moving on to number 5. We have another set. Now, in this case here, my boundary is at 2. So I'm going to go ahead and mark out my boundary. And this one's +2. And I'm going to just graph it. Now, this is, again, y equals -5 over 2x minus 1. So let's go ahead and graph it. Start with the y-intercept at -1, and then down 5 over 2. So it would look something like that. And I'm going to try my best to go up 5 over 2. All right, that's probably about as close as I can get. And like I said, it's really good to be precise because sometimes you might need to read these graphs, and it helps to know exactly where, as close as you can, where the lines are crossing. So anyway, there we go. That's the first one, and let's go ahead and graph this second one. Now the y-intercept is right here at 2. Okay. And I have to go up 1 over 1, something like this. But I'm going to have to erase this part of the line because that's not, we can't have that there because this yellow line only, the orange line only exists for x values greater than 2. Now I'm going to have to erase my boundary line just because, again, that's not part of the function. We don't need that. It's not part of the answer at all. And you don't want it to be confused with anything else. Okay, so cap them off. X less than 2. So there is no or equal to. So I'm going to go ahead and put a open circle on there. Because again, there's no or equal to, so we can't land on the green line there. And for x values greater than 2, and that one also has a hole there too. So I end up with a hole in the graph, a hole in the domain. So if I'm trying to like find x values, you know, I can, if I put in say x of -2, the y will be 4. My output is 4. But if I say, what is the for the input of 2, what is my output? They both have holes in the function at 2, so neither of them. So that's what a hole in the graph looks like. There's a, but I can pick anything greater than 2, anything less than 2. I just can't pick 2. So I'm going to keep it kind of easy. We would have to write, normally we'd have to write this in set builder notation. But you can just say domain is everything except 2. So I just put that /equal sign, meaning not equal to. So x not equal to 2. And again, maybe I'll just go ahead and mention it here, because I know some people are pretty good at set builder notation. But set builder notation would look something like that, and it would read any x such that x is not 2. And again, that just means anything as long as it's not 2. Or you could put like all real numbers except x equals 2. I don't know. Or just keep it very simple like the way I did. Just say x is not 2. Now for the range, we always start with the bottom and work our way up. So just like the way you work from left to right, we're going to work from the bottom up. And eventually when we keep going up, we're going to run into that green line. Now there is a hole there, which says that we cannot pick anything, in this case, less than -6. So y has to be greater than -6. Now, if this was a filled circle, you could put an or equal to, well, you should put an or equal to on the bottom like that. But in this case, we don't need to because we can't pick -6. But what if you were to pick, say, -5.9? If you were to, now -5.9 is like a little bit above there, and yes, you can pick that, but you can't go to 6. You could pick like -5.9999, and you would still get a solution. You would still get an output from that, but yeah, you just can't pick 6. But everything above that, now these lines, they go up forever in both directions. So anything above 6 works out. Okay, moving on. So this one has 3 parts of the line. Now check for breaks. Now usually when you have a boundary, they usually end at the same place. Now these both end at -5. Oopsie. Get the right kind of line. So -5. There you go. You know, that line actually wasn't too bad. So there's the first one. And now we have x is greater than 1. Okay, now to graph these, again, this is just y equals -1, which means there is no x and there is no slope. So it's just going to be -1. So I'm just going to have a line that runs to -1, and I need a solid line for this one here. So run a line from here to -1. I'm going to stop a little bit short so that way I can fill it with a filled circle or a hollow circle later. Now I have the second segment for the areas of x between -5 and 1, which again, that means everything in this area here. And they give us this function, so y equals -x minus 3. Start at the y-intercept and go down 1 over 1, following the slope of -1. And we have a line kind of like that. And for the third section, I'm going to go ahead and use purple. And again, this is just y equals 6. So there's no slope. It's just y is always going to be 6. Now I should mark it from up here like this. Okay, but now this is so close and the slope is easy, pretty easy to find. So, you know, you could probably just draw it just like that. Okay, now I'm gonna get rid of my boundary markers because again, those are just there to help us remember where the line ends. And let's start filling these out. So I have x is less than or equal to -5. So this means since I have the or equal to, I'm going to use a filled circle here. For here, I'm going to use a open circle because both of these do not have the or equal to. So open circle, open circle. There we go. And for the purple line, our third line, x values greater than or equal to 1. Now again, since that one has the or equal to, that's the number that takes over if x equals 1. And again, if you're plugging numbers in, just like you remember the first two exercises, if I were to plug in 1, I would have to use this function here. Now here I have another, well, let's go ahead and calculate the domain. So starting from left to right, okay, there's a hole in the orange function, but luckily that's covered by the green one. So there's no gap there. And then there's a hole here on the orange one, but it's covered by the purple one. And both lines go on forever in both directions. So that means all real numbers. And these ranges can sometimes be a little tricky. Like in this case here, starting from the bottom, our lowest value, now don't write this one just yet because we're gonna have to turn it around a little bit. So the lowest number we can pick is -4. Now y has to be, okay, never mind. I tried to write it wrong, but I accidentally wrote it the correct way. All right, so again, y has to be greater than -4. And it has to be, y also has to be less than 2. Because I'm talking about, like, if you look at that orange line, there's like a little space where they both kind of inhabit the y values for that area. And to help you imagine it, I'm going to shade in what it would look like. The range is, I can pick a y value for anything in this shaded area. Now, you don't need to shade it. I'm just showing you visually that that is the range. Okay, I can pick any area, anything in that area and get a y value from it. But we also have a second part that is a disjointed, that is not part of the regular, line of range, right? We have that purple area that's all by itself, just up there hanging out all by itself. So we have another separate range of y equals 6. And again, union is like the way you think of union means together, like a workers' union. That's kind of what, you know, kind of means the same thing. It means together. The range is numbers. The range is numbers between -4 and 2, and the number 6. So I understand that's a little bit confusing, and you know, I was thinking about this, and I think I'm going to kind of go easy on the domain and range part. For this assignment, the main thing, the main focus that I'm looking for is the graph. Is the graph largely correct? Okay, number 7. So check for the breaks. So I have a break in the x values from -2, and again it's -2. And be careful because I don't know if they would do this, but sometimes they can have like a big gap between two numbers and nothing in between. That's kind of possible, but I don't see it all that often. But anyway, yeah, they both break at -2, so I'm going to put a light line right here. I'm going to just leave it that way, even though I've been using dash lines lately for that. 4, so I have another one at 4, so I have a matching 4 here. So that's just, again, those are just there to tell me, be careful because your line is going to have to stop right there when graphing it. Okay, so for my first segment, we have y equals 2x. And there's no regular number. And if we use identity property, remember that means 2x plus 0 is the same thing. So that means it starts from the origin, from the middle of the whole graph, and up 2 over 1, up 2 over 1, up 2 over 1. And it would look like this if it continued on forever the way it should, but it doesn't. We got to stop at this. We got to stop right here. Yeah, that looks about right. And again, for x values between -2 and 4, which is this area here in the middle, we're going to use this one. Now, this one might be a little bit of a tricky one because it's not in slope-intercept form. So I'm going to put it in slope-intercept form because x is supposed to go first. Now, in this case, you know, they're both -1, so it's not like you would have, even if you completely forgot to put it in slope-intercept form, you probably would have graphed it the correct way anyway. But I noticed that that is something students will do, is that they will graph a line that's not in slope-intercept form and assume that the first number is the slope and the second number, in this case with the x, is going to be the y-intercept. Just to give you an idea, that would look something kind of like this, but if -3 was the first number, and like it was -3 minus x, then people will mix up their slope and their intercept. Okay, but anyway, let's go ahead and graph that. So -1, and it goes down 1 over 1. Okay, that's a pretty easy one to graph. Oops, I almost went a little bit off. And there we go, there's our middle section. And the third section here for x values greater than 4, which is this area, we get y equals -3. So this is just a straight line at -3, just like that. And again, I'm going to delete these lines just because we don't need them. They're not part of the solution. And in fact, if you leave them in there, some people might get confused and they might mistake that as part of the, part of your work. Which I don't think that's good, not for me at least. That's not something I would really mess up on that badly, but you never know. I always tell people you got to watch out because anyone who knows me knows I've had a lot of jobs in the past, and it's weird because sometimes you do run into bosses that are like, you're the boss, you should know this sort of thing. But a lot of times they don't, I had a boss one time that didn't know, I forgot what I did. I put something like, I put a negative number on a report and he goes, "What does this mean?" And I'm like, "You serious?" It probably wasn't something like that. It might've been like a symbol or something, but I knew it was something simple that everybody knows. I think it was like but you never know. Someone, like if you have a job and you mark something that's a little bit different, someone's going to get confused and completely take the wrong thing from it. By the way, I'm not talking about my current job. This is like 5 years ago or so. Just in case my boss is watching this. Anyway, so let's go ahead and cap these off. So for the first green segment, we have an or equal to. So I'm going to go ahead and fill this in. And here we have no or equal to on either side, on the the -2 side or the 4 side. So that's going to be open circle, And for the purple line, it looks like we do have an or equal to. So this line should have no gaps. No gaps, no holes, no jumps. So it's a continuous domain all the way from one side to the other. So that would mean that this is an all reals domain. Range, so calculating it from the bottom, working our way up. Yeah, there are some areas that we end up with touching more than one line. But right when we get to about the top of the orange line, there's a hole there. So in this case, we want y values less than 1. Because one is the highest area we have. We have nothing above there. There would be no way for us to get, like, say, a y of 6, right? If I ask, okay, what do I have to do to get a y of 6? And we look at these, it's not possible. We can't get 6 as an output for any of those functions. But if you wanted, like, an output of, say, if y was -4, you could choose here or you could choose there, right? And some graphs do that. Some graphs, like parabolas, you can get 2 intersections out of them. But that's only the possible y, so you can't pick any y's greater than 1. All right, so let me go ahead and move to the last one, actually. Another 3-segment area. I'm going to use my line to mark out where these end, where each of the areas are. So I'm going to go ahead and put here, like that. Okay, it's a good thing I use a dash line because it's a little bit easier to see. Now, I'm not sure how you could do this. One thing that I was suggesting too is to kind of like point out, but this is mainly for yourself here because you want to stop the graph at this part, this line here, right? Because you have 3 separate areas. And it looks like you have another break at 6. So both of these break at 6. So mark out 6 on our graph. And now we can start putting the lines on there. And let's see, no y-intercept. So that means it's going to cross the middle. Down 3/1, down 3/1, down 3/1. But again, we don't need that area down there. Oh, let's see. So we got to stop it right about there. Let's see, down 3/1. Why am I having a hard time graphing this one? Okay, I think it's going to be like this. All right, it's a little bit off. It should be a little bit more. It should be a little bit more angled. Oh well, whatever. Like I said, I'm not. As long as your graphs are in the right area. And in this case here, I'm going to have to open circle. Or actually, I'm doing things a little bit differently. But that would be an open circle for that one. All right, now we got to graph the middle segment. So this would be -1. And then follow the slope. So that's down 1/2, down 1/2, down 1/2. And when doing this, make sure that you have the slope. Okay, so I have a lot of students that when they're graphing lines, they never bother to check the slope. So remember, slopes go down if they are negative and up if they're positive. So like I'll get some students that forget lines can go down, and I'll look at a paper as soon as I open it, like all the lines are going up, and I'm like, okay, like half of these aren't going to make it. So make sure you watch out for the direction of your negative. All right, so let's go ahead and graph our final line. X equals -7. So my line starts at -7, goes up 1/1, all the way this way. But I have to shorten the line so that it starts on this side here. like that. I'm going to erase my lines that were there to remind me where to stop the lines. And let's go ahead and start filling them in. So here I have an open circle. Not a very good, kind of looks like it's got a swirl in there or something, but that's an open circle on the green line. On the 0 side of the orange line, there is an or equal to. So that's why I fill it in. On the 6 side of the orange line, there is none. So I'm going to use an open circle. And for the 3rd segment, 3rd line, there is no or equal to either. And that's going to leave a hole right here in our domain. And again, you can pick any x such that x sort of thing. You can make it look like that. But I'm going to keep it kind of simple today, and I'm going to say x cannot be 6. So just / equal sign. Yeah, close enough. So x is not 6. You cannot have anything there. Okay, this gap is covered. That one is not. There's a small hole in the domain right there. And for the range, so again, starting from the bottom, we have nothing from -infinity until we get to y greater than. So y value is greater than, looks like 4. And this is why it's a good idea to draw the graph really nice and make sure you get your slopes pointed in the right direction and everything, because if you don't do this, you can easily, mark the wrong area. And I think that's it. Everything between there is covered, because I don't think there's any more gaps in there. And it looks like we're done with that one. So I guess we're done. Let me just check something other really quickly, because I thought there was maybe, let's see. Okay, I got that one covered. Okay. Okay, I thought I missed one of them with the 2 separate ranges, but I guess I did. So I was like, I just had that feeling like I knew there were supposed to be 2 of them, but I don't remember both of them. Anyway, so that's it for today. Hope you enjoyed this lesson. I'll be around for another minute or 2 if you have any questions. If not, well, I'll see you tomorrow. Bye-bye.